Alright guys, welcome to this set of videos. What we're going to do in this set of videos is they will follow along with the notes out of your guys' textbook, which come from Chapter 2, Section 8. Now, what we've been doing, the theme really of Chapter 2 here has been graphing, and particularly graphing linear functions, So we looked at the different types of equations for linear functions. There is the standard form for a linear function, there is the slope-intercept form, and there is the point-slope equation for a line, and all of those just give us a way of either writing the equation for a line or graphing the equation of a line. And then from there, what we did is we looked at parallel and perpendicular lines. So what do you do when you're given a linear function and you're asked to find a line that is parallel or perpendicular to it? And so we looked at all of that primarily in sections 1 through 4 of this chapter. And then what we did is we kind of made a little bit of a switch, and in sections 6 and 7 of this chapter, we began to look at special functions. And I told you guys that when we were doing those sections, that we would see that theme repeated for the rest of the year. Graphing is going to show up in every chapter that we're going to do here in Algebra 2. And so we're kind of giving you an introduction into what to expect as we get into later chapters. And so what we did in section 6 was we talked about some special functions. We talked about the greatest integer function. That is the graph that looks like a series of horizontal line segments, also known as the step function because it kind of looks like a set of stairs. We talked about the absolute value function, which we're actually going to work with a little bit more here in this section. And we noticed that the absolute value graph always looks like a V, right? And that V could be a V opening up, could be a V opening down. We could move it around. And then we talked about the piecewise defined functions. And the thing about those, although they look scary, we recognize, well, they're really not that bad. What you have are just a number of different pieces that are required in order to define the entire function. And so what we wound up with when we graphed them was more than one line on our graph. But when you put those all of those lines together, you see the entire function. Then we went into section 7, where we talked about transformations. And I told you guys that transformations is a word you will hear me use in every chapter throughout the rest of Algebra 2. In fact, I will even say to you, all right guys, we're going to do transformations. Remember back to chapter 2 here we go. Let's do transformations, but now we're going to do it with whatever the topic is we're studying in that particular chapter. When it came to transformations, you guys needed to find the A, the H, and the K value, right? A was the dilation. Am I stretching my graph or am I compressing my graph? H was the horizontal shift, right? Shift left and right. And you had to remember that with H, whatever the sign of H is, the shift will be in the opposite direction, right? So if H is negative, you actually go in the positive direction. If H is positive, you'd actually go in the negative direction. And then there was K. K is the vertical shift, and K works the way that we would want it to. If K is positive, you go up, and if K is negative, you go down. And so we're seeing this theme of graphing. And this section here, Chapter 2, Section 8, is going to be absolutely no different. What we're going to be doing here is graphing inequalities. Now, you guys were introduced to graphing inequalities in Algebra 1. And so this should just be a refresher for you on how to graph inequalities. So, a couple of things about objectives or learning targets as we go through these notes. First thing you need to be able to do by the time we get to the end is, of course, graph linear inequalities. And so we'll look at those first. And then the next thing I'm going to have you guys do is graph absolute value inequalities. I mentioned a second ago we're going to look at absolute value graphs again in this section. And this is where it's going to be, right? We'll be graphing those absolute values and shading the appropriate portion of the region. And that's kind of a little foreshadowing, or hopefully brings back to memory what the when you graph inequalities, what we're actually doing. So here we go. You should remember inequalities as the graphs you would do. You put your line onto the graph, and then you had to shade a certain region of the graph. And the deal with the shaded region, right, is that shaded region represents all of the solutions to our inequality. Pick any point inside the shaded region and it represents a solution that satisfies the inequality. It gives you a true statement. A true statement. So that's what we're going to be working on here. We're going to be working on graphing both linear inequalities and absolute value inequalities and shading the appropriate region of the graph. And the way that we do that are actually 4 very simple steps. So let's just refresh ourselves, run through those 4 simple steps, and then we'll actually do some graphs. So here's how you guys are going to graph these inequalities. Step 1, we ignore the inequality symbol. Just completely forget about the inequality. We don't care what it is. Replace the inequality with an equal sign and graph the equation that you were given. All right, you just graph the equation. Once I've graphed the equation by ignoring the inequality symbol, we go to step 2, and now is where I have to account for the fact that it's an inequality. The first thing I'm going to do right here in step 2, do I need a solid or dashed line? And the way that that works is you will use a solid line. We will use a solid line if the inequality is less than or equal to or greater than or equal to. Let me make a quick note for you about that, right? So the solid line is going to be greater than or equal to or less than or equal to. That will all get you a solid line. The dotted line is going to come if you are strictly less than or strictly greater than. So strictly less than or strictly greater than, that's how you're going to get a dotted line. And remember, the equal to means that the line would be included. That's why we draw a solid line, because the line, any point on the line, is also a solution. It satisfies the inequality. But when it comes to strictly less than or strictly greater than, the line is not part of the solution. If you pick points that fall directly on the line, they do not satisfy the inequality. They don't give you a true statement. And so we'll use a dotted line just to say to people, hey, the shaded region is your solution, but that dotted line doesn't count, right? It's not included in the solution set for the inequality. So that's step 2. Step 3, we're going to choose a test point. Guys, we always want to work smarter, not harder. You like to use this point right here, 0, 0, because 0, 0 is easy to do math with. But there's one reason why you wouldn't be able to use 0, 0, and that's if your line passes through the point 0, 0. It won't happen that often. In fact, it's highly unlikely that your graphs will go through the point 0, 0. So 99% of the time, you're going to use 0, 0 as your test point. But if your line does go through the point 0, 0, just pick something else that's really easy to do math with that your line doesn't go through, like maybe 2, 2, or you could do -1, -1, right? Something like that, just a real easy point. It doesn't have to be anything crazy. Work smarter, not harder. Pick something easy. And then finally, step 4. Now that I've chosen my test point, I'm going to plug that point into my inequality. All right, I go back to the equation I was originally given. I plug 0, 0, or whatever your test point is into the inequality and evaluate it. You're either going to get a true statement or you're going to get a false statement. And this is where sometimes kids get a little bit confused, right? So we'll definitely, I'll make sure I highlight this for you when we do the example problems here in a second. But when it comes to the test point, right, your test point's going to be on one side of the line or the other, right? Either your test point will be above the line or your test point will be below the line. Your test point may be to the left of the line or it might be to the right of the line, right? But your test point's going to be on one side of the line or the other. That's why we can't choose a test point that falls on the line, right? If your line goes through 0, 0, I can't use it. I don't want my test point to be a point on the line. It's either got to be above, below, left, or right of my line. Now, when I plug my test point in, if I get a true statement, that means my test point is a solution. And everything that is on the same side as my test point, right? So if my test point was above the line, well, everybody above the line is going to give me a true statement. And so I would shade above the line. But if my test point is below the line, well, then everybody below the line is going to be my shaded region because my test point gave me a true statement. But what if your test point gives you a false statement? Well, that means that your test point is not a solution, right? So if my test point was above the line and I got a false statement, well, that means that my solution region is not above the line because I got a false statement. My solution region would be below the line. So I'd shade everybody on the opposite side if I got a false statement. The vice versa is true if my test point was below the line and I got a false statement. Well, that means the points below the line are not solutions. They don't satisfy my inequality, so I would shade everybody above the line, right? That's where I'm going to find my true statements. And again, if you didn't quite follow me there, don't worry, we're going to do a bunch of examples here on the next page. And I promise you, I'll go through all 4 steps and it'll make a lot more sense. So let's just jump right into it. Head on over to the next page in the notes. We'll look at some example problems and I'll meet you there.